The skeleton inside every building around you was not invented by an engineer. It was discovered by a gardener named Joseph Monier, who had no engineering training and a problem with cracked flower pots. He shoved iron mesh into cement so they would not break. The buildings never stopped rising, and the man whose name still labels an entire industry died broke, petitioning the president of France for a tobacco kiosk. That is reinforced concrete in 4 sentences. The rest is how it happened, and why the popular version never quite tells the truth. The popular version of reinforced concrete treats it like electricity, or the steam engine. A thing that emerged from civilization's workshop, the work of no single person in particular. If an individual is named at all, it is usually François Hennebique, the French contractor who patented a complete building system in 1892, or the German engineers of the so-called Monierbau system. Either way, the credit goes to professionals working inside engineering, to people who knew what they were doing. The actual story starts in a village of potters in southern France, in the hills near Uzès. Joseph Monier was born on 8th November 1823 in Saint-Quentin-la-Poterie, a village of potters just north of Uzès, the 6th of 10 children in a family that tended gardens for the local duke. According to one legend, when the village abbey offered to send the 14-year-old boy off to school, his mother refused, saying he was too smart for school. He never received formal schooling as a child. He learned to read and write in evening classes in Paris after he arrived there at 17. The Duke of Uzès hired the boy to work in the gardens of the Duke's Paris mansion. By 1846, Monier had moved to the Tuileries Gardens, the formal grounds behind the Louvre. There, he became responsible for one of the more peculiar jobs in 19th century horticulture, the orangery. The Tuileries kept dozens of mature orange trees in large ceramic pots, and the trees had to be moved indoors each winter and back out each spring. The pots kept cracking. Some broke in transit on the carts moving between the open garden and the greenhouse. Mature orange trees do not survive having their pots shatter under them. The damage was constant and embarrassing to the imperial gardens. Monier could not find a ceramic thick enough to take the strain. He tried cement. The cement cracked. Concrete, the mixture of cement, sand, gravel, and water that the Romans had used to build the dome of the Pantheon in 128 CE, has always been strong under compression. Pile weight on top of it, and it carries the load. But concrete is weak under tension. Bend it, stretch it, ask it to flex. It splits open. Every Roman engineer understood this. Their entire solution, the Pantheon included, was to keep the concrete permanently under compression. Build thick domes, build arches, build only shapes that push the material inward. For almost 1800 years, that was the only answer anyone had. Monier did not know any of this as theory. He knew only that his pots cracked. He had no theorems. He had no equations. He had a problem, and he had access to a potting shed where he could mix whatever combination he wanted and watch what broke and what held. Most 19th century problem solvers would have commissioned a study. Monier had no use for that. He was outside the system that commissioned studies, and that turned out to matter. How does a man with no training solve what trained men could not? The answer was not in any textbook. It was in a flower pot. The answer, when it came, had no theory behind it. Monier started mixing cement with sand, cinders, crushed fire bricks. He poured pots. They cracked. He tried again. They cracked. And then, sometime in the late 1840s, he embedded an iron mesh inside the wet cement. A simple grid of iron rods, the cheapest and most accessible form of metalwork available to a man of his means. The pots stopped breaking. Why this worked in structural terms is that concrete and iron have a near-perfect partnership under stress. The concrete carries the load pushed onto it. The iron carries the load that tries to pull it apart. The two materials compensate for each other's weaknesses. But Monier did not arrive at this by reasoning about load paths or tensile stresses. He arrived at it by trying pots in a shed until they stopped splitting. His employers and peers were not impressed. There was a general notion at the time that the thermal expansion and contraction of embedded iron would rupture the concrete around the rods. Critics also worried that wet cement would rust the iron, making it porous and worthless. Monier spent years experimenting to prove these warnings wrong. He watched his reinforced pots through seasons of rain, frost, and heat. He watched them survive the moves between the Tuileries Orangery and the open garden. He watched the orange trees stop losing their containers on the way to the greenhouse. He did not publish. He did not lecture at any learned society. He filed for a patent. In July 1867, Monier received a French patent for iron-reinforced troughs for horticulture. Concrete tubs, basins, planters. That same month, he exhibited the invention at the Paris Exposition Universelle, the great international fair where nations showed off their progress. He had a stand among the gardeners, not among the engineers. Most of the people who passed were not paying attention to reinforced concrete. They were looking at the new phonographs and the latest fashions. Monier kept patenting. In 1868, he covered reinforced pipes and basins. In 1869, he added panels for building facades. In 1873, he added bridges. Each patent required a fresh argument with the patent office, which did not always believe him. Each new shape required him to invent a way to make the iron sit properly inside the cement. And that was different for a trough than for a pipe than for a beam. By 1875, the first reinforced concrete bridge in his name was built across the moat at the Castle of Chazelles, in the Indre department of central France, with a span reported between roughly 13, 8, and 16.5 meters. The bridge still exists. It is a thin concrete arch across what was once a moat. Understated, almost easy to miss. It was a modest bridge for a modest estate, but it was the first of its kind, and it was years ahead of any other reinforced concrete structure of comparable scale. The pot had become a pipeline. The pipeline had become a panel. The panel had become a beam. The beam had become a bridge. The gardener had accumulated a portfolio of patents on materials that the engineering journals were still arguing about. But each step required new permission. The potting shed technique had to be revalidated for every new shape, every new use, every new claim. The trials never stopped. He was not alone. He thought he was because patents were filed in single names and exhibitions attracted single viewers. But reinforced concrete was not a solitary eureka. It was a near simultaneous discovery by at least 4 people groping toward the same idea in different countries. In the south of France, an inventor named Joseph Louis Lambot had built a small rowboat out of cement mortar, reinforced with iron bars and wire mesh. He built it in 1848, 19 years before Monier's first patent. Lambot was from a country estate in Miraval. He was trying to make a boat that would not rot in the water. His boat was exhibited at the Paris Exposition Universelle in 1855, 12 years before Monier exhibited his pots. Lambot patented his invention, which he called furcement, in Belgium in early 1855. He had the idea. He had a working demonstration. He had the patent in one country for boats. He never extended it to buildings. The boat eventually sank, was recovered a century later, and is now displayed in a museum in Brignoles, the Musée des Contes de Provence, in the Var. In Newcastle upon Tyne, William Boutland Wilkinson filed an English patent in 1854 for an iron-reinforced concrete floor. He understood something Monier never quite grasped, that the iron needed to be placed on the tensile side of a beam where the pulling force was greatest. Wilkinson built a small servant's cottage using his system. He patented in England only. He did not commercialize or scale. He did not build an industry. Near Paris, François Coignet built a 4-story house entirely of reinforced concrete in Saint-Denis in 1853, 14 years before Monier's first patent. The walls were made of prefabricated reinforced blocks. The floors were timber encased in concrete. The roof was iron joists encased in concrete. Coignet's family ran a cement factory, and the house was partly a publicity stunt. Coignet patented concrete with clinker aggregate in 1854 and published a book in 1861 describing applications of the method. He built an 87-mile aqueduct with arches up to 40 meters high between 1867 and 1874. He never consolidated his ideas into a single clean patent. In New York, a man named Thaddeus Hyatt had begun experiments on reinforced concrete beams in the 1850s. His work remained private until 1877, when he self-published his results. He received a U.S. patent in 1878. Hyatt had spent 2 decades working in obscurity on a problem nobody had asked him to solve. He was also an abolitionist, a friend of John Brown, and a man with divided energies. 4 other people in 3 different countries, working independently, arrived at the same insight within a few decades of each other. None of them built an industry around their version of the discovery. Monier did. He patented in more countries. He patented across a wider range of applications. He sold his patents to people who could scale what he had stumbled on. The discovery was inevitable. The gardener was not. Here is the part of the story that does not fit the popular version. The engineers of Monier's era knew concrete failed under tension. They had known it since the Romans. They responded like engineers. They tried to fix the material. Better mixes, stronger formulas, cleaner cement, denser aggregates. They chased a hypothetical perfect concrete that would never crack. Some of them spent entire careers on the project. None of them solved it because concrete cannot be made to resist tension reliably. The property is fundamental to the chemistry of the material. Monier never internalized this paradigm. He had no paradigm to internalize. He had no textbooks, no professors, no learned society to constrain his thinking. The trained men of the era had tools Monier did not. They had laboratories, access to journals, the time to theorize. What they did not have was the freedom to ignore the assumptions of their field. Monier had that freedom because he had never been told the assumptions. He was free because he was untrained. The advantage was not luck. It was the absence of a particular kind of knowledge. When concrete cracked, he did not say the concrete was wrong. He said the concrete was not enough. He accepted the failure and looked for something else to compensate. That is reinforced concrete's real intellectual leap. Not the mesh itself, but the move from fix the material to compensate for the material. It is a conceptual shift that sounds obvious in hindsight. It was not obvious at the time. And it came from a man who could not have made it inside the discipline because the discipline was looking the other way. The shift unlocked everything. By 1887, a German engineer named Gustav Adolf Weiss had acquired all of Monier's patents in Germany and Austria and consolidated them into a system he called Monierbau. Weiss branded the technique with the gardener's name. He and his partner, the engineer Matthias Koenen, ran the tests and derived the first real theory of reinforced concrete plates in 1886. Between the mid-1880s and 1891, Weiss's company built roughly 320 reinforced concrete arch bridges throughout Europe using Monier's design. The gardener's name became the industry standard for the new technique. In 1892, the French contractor François Hennebique patented an even more ambitious system. Hennebique's innovation was not a single material, but a complete building system. Beams, columns, floors, all reinforced, all integrated, all designed to work together. Between 1892 and 1902, more than 7,000 structures were built using his system. By 1903, Hennebique's patent was declared invalid, and Monier's earlier patent was reinstated. A legal technicality that helps explain why the gardener's name outlived the contractor's. The Ingalls building in Cincinnati, completed in 1903, was 16 stories tall. It was the first reinforced concrete skyscraper. It rose, floor by floor, with steel mesh and poured concrete doing the work that stone and iron had done for centuries, only lighter and in taller buildings. Critics at the time genuinely expected the building to collapse under its own weight. It did not. Reinforced concrete had arrived, and it was here to stay. The vertical city was possible. The dam was possible. The highway overpass was possible. The stadium roof was possible. None of it would have happened without a man in Paris deciding that his pots needed a metal skeleton. And there is a strange kind of symmetry in that. The discipline that had been searching for the answer spent decades inside the wrong problem. The man who was not searching for it at all found the right answer, because he did not know enough to look for the wrong one. Every modern building rests on the same logic Monier worked out in his potting shed. Concrete carries the compression. Iron carries the tension. The two materials compensate for each other. Every bridge, every column, every beam, every slab you have ever walked on applies the principle a gardener stumbled on while trying to save his orange trees. In 1888, while his name was already being stamped on construction sites across Europe, Joseph Monier filed for bankruptcy. By then, Weiss and others were already building empires under his name. Companies across Europe were selling products and structures stamped with the gardener's brand. Monier's name appeared on construction sites from Frankfurt to Buenos Aires. The man himself was being harassed by bailiffs and tax authorities who reasoned that someone with so many patents must be sitting on a fortune. He was not. The licenses had been sold. The royalties had been spent. The man whose name lived above every door was inside his own apartment trying to keep the lights on. In 1902, foreign firms that had built their businesses on Monier's patents petitioned the president of France to grant him a pension. They called him the inventor of reinforced concrete. They called him their former master. A subscription was opened. Failing the pension, the petitioners asked that he be granted a tobacco kiosk to run, a small concession so the old gardener might earn a living in his final years. Monier expressed his gratitude for the efforts on his behalf in a letter published in the journal Le Ciment in 1902. He died 4 years later, in March 1906, in Paris, in poverty. He was 82. The water reservoir he built for an old people's home in Clamart near Paris was his last major project. It is a round concrete structure 10 meters high, and it was still standing when the photographs of the early 21st century were taken. He had built troughs, pipes, panels, beams, bridges, and reservoirs by then, the entire range of what his patented technique could do. Why does the name Monier survive on every construction site when Monier himself died unable to afford one? Because Weiss chose to brand his technique as Monierbau. The label stamped every construction site, every manual, every training school in Europe and eventually across the world. Engineers who had never met Monier wrote his name into their specifications without thinking about who he was. The honor was real, but it was also useful. Calling a technique by the name of its inventor signaled credibility. The industry got the credibility. The inventor got the legacy and almost nothing else. The persistence mechanism is straightforward. The name was useful. The man, after a certain point, was not. The label stuck because other people kept using it. The man who could not write his own name as a child ended up signing an entire industry, but with no idea how to cash the check. Stand in any room of any building anywhere on Earth. The floor under your feet is held up by a frame of steel reinforcement, bonded to the concrete you cannot see, working as a single material. That frame was discovered by a gardener trying to keep orange trees in unbroken pots. The story of reinforced concrete is not really the story of a discovery. It is the story of a man who was ignorant of the way the problem was supposed to be solved, and who therefore solved it. The trained engineers of the 19th century spent decades trying to make the material better. Monier accepted that the material could not be made better, and he added something else to to do the work the concrete could not do. That single act of reasoning, performed by an outsider inside a potting shed, made the modern city possible. The skeleton inside every building around you was discovered by accident, by someone who did not know he was solving one of the great problems of engineering, and who could not afford to live in any of the buildings his discovery made possible. The orange trees at the Tuileries died eventually, the way all living things do. The pas Monier built for them held. If this changed the way you think about the next building you walk into, tell us where you were when you realized concrete has a skeleton. And if you want more origin stories like this one, every week we trace a thing you take for granted back to the moment it was invented.